Hello, this video is for chapter 1.4, an inverse function. So what is inverse function? Inverse function is another function from an original function f of x. If f of x, the original one, is a one-to-one function, then there is an inverse function. And what is it used for? Inverse function is a function that reverses the operation of f on x. So get a pen. So you can think of it as start off with an x and then use the function f to get a output f of x. But then you can divide another function so that it go back to x. You have the y go back to x using this new function called inverse. Okay, so now the label for the inverse function is f of power -1. It seems like a power, but it's just a label. It's just a name. So the inverse function f of -1 does not mean 1 over. So -1 is not 1 over f of 1f, because this f is just a name. So you can think of it as a symbol. This symbol just represents an inverse function. I want to mention again that this only works, the inverse only exists if f is 1-to-1. What is 1-to-1? 1-to-1 is a function that has the property where every unique x would go to a y. If this is the first one, it go to the second, we go to y1, the second one go to y2, etc. They never share the output. So technically, analytically, we can say if f of x1 equal to f of x2, this implies x1 is equal to x2. It is a unique x that go to 1y. To check if a original function is 1-to-1, we can also use the horizontal line test. So for example, you have any function that's like this, and you can just check that horizontally, if you draw any horizontal line, it would only cut the function at one point. Okay, so the next things we want to go over is how do we find the inverse function? If I have the original inverse function formula, how do I find it? Now, this process is the more popular one. The book uses a two-step process, which is a little faster, but it's not as popular. So what we usually do is we write the function as y equal, we switch x and y, because what happened is x go to y for f, but inverse would reverse the function so that y go to x. So we switch x and y, the x become the input, the output, y become the input. We solve for y, and that would be our inverse function. If we want to find the inverse function by graphing, we can reflect the original f of x over y equal to x, because what happened is every point x, y on f, which corresponds to having a point of y comma x on f of inverse, because the inverse function basically take the output y, go back to x. This would be the new input for f inverse. Okay, so let's do an example on finding the inverse of a rational function and a cube function. So these are one-to-one function. So let's try to find it. So use our method. First of all, we write it as y equal to x minus 2 over 3x plus 1. Then we switch x and y. X become y minus 2 over 3y plus 1. So step 1, step 2, step 3, we got to solve for y. This is the step that involve a lot of work. You see how we have y over on two different locations. How can I solve for y? So first of all, we would clear this denominator by multiplying 3y plus 1 on both sides. We go to y minus 2 times 3y plus 1. So it is 3y plus 1. And you would cancel it, and this would be 3y plus 1, right? So the goal is to cancel this. And now I have 3xy plus x equal to y minus 2. Now, to solve for y, I have to have all y terms on one side. So let's do minus x plus 2, no, minus y and a minus y. So on this side, I would have 3xy minus y, no more x. And on this side, I would have my y goes away. I have negative 2 minus x. So all the y's are on this side. I'm going to factor it. Y 3x minus 1 is equal to negative 2 minus x. Okay, so then I would divide both sides by 3x minus 1. Y would be negative 2 minus x over 3x minus 1. And that would be the inverse. So the answer would be my F inverse is this formula. Negative 2 minus x over 3x minus 1. Okay, so this is the answer. So the trick is you have to factor y. Move all the y terms on one side and factor y. Let's find the inverse for a cube function. So how do I do it? So first is y equal to 2x cubed minus 5. Don't need to do anything. Just write this as y. Switch x and y because I want to do the inverse now. Solve for y. So add 5 on both sides. So I have 2y cubed. To solve for y, I have to do the cube root, but I need to clean up the 2 first. So y cubed is equal to x plus 5 over 2. So now I'm ready to do my y cube. So I would cube on both sides. Y would equal to cube root of x plus 5 over 2, and that is my inverse function. Inverse function of x now become cube root of x plus 5 over 2. What about if I have a function that does not pass the horizontal line test, like this quadratic function, and also a lot of the sine, cosine, trig function does not pass the horizontal line test because they are periodical. So in order to find inverse for them, I can restrict the original function's domain, restrict the domain of f, so that it becomes a one-to-one function. So let's think about this. This function is x plus 3 squared minus 1 is a quadratic function. It's a parabola. If I graph it, I would graph it by down 1 and also shift to the left by 3. Down 1. So this function should be here like this. You see how technically, if I do a horizontal line, these I would cut two points. So to restrict it, I would just start from the vertex. This is a negative 3, negative 1. Start from here. I'm just going to restrict my function to only consider the domain. Of course, you can restrict the other side also, but it's just, it's really up to you. So we would do start from my x from x is greater than or equal to negative 3. And this would make this function a one-to-one. And then you can use the method that we have used before to find the inverse function. Likewise, in sine and cosine and tangent function, we have to restrict our domains. Otherwise, it would not be a one-to-one function. So how do I restrict the sine x domain? So the domain, sine was like this, right? Like this. So we will restrict our domain to here from negative pi over 2, is actually including, and pi over 2. Okay, in the unit circle, it would means I would only consider this and the quadrant 1 and quadrant 4. Okay. For cosine, I would restrict the cosine to, so cosine was like this, right? I would restrict this to be on this part from 0 to pi. It would take all the part, it would span positive and negative of the function. What about tangent? So for tangent, we would do the same for negative pi over 2, just like sine, and pi over 2. So meaning we would take this part how tangent has this pi over 2, negative pi over 2, and pi over 2 graph. So once we do that, we would know how to evaluate the inverse function. To evaluate the inverse function, this is the y value from sine, and I'm supposed to get an angle, right? Theta. That would mean so that sine theta is negative 1/2. Now, but this is not solving an equation, it's an inverse function that I'm supposed to only get from this quadrant and this quadrant. So where would in this quadrant where sine would be negative 1/2 would be this one, negative pi over 3. So theta equal to negative pi over, not 3, negative pi over 6. This is a root 3 over 2, a negative 1/2, right? And the same for cosine inverse, negative root 2 over 2. So it would be an angle that would give negative root 2 over 2. And for cosine, we restrict it into 0 to pi. So I'm supposed to look at quadrant 1 and quadrant 2. So in what place would this be? So this would be here as 3 pi over 4, right? So this is the point where I have a x-coordinate of negative root 2 over 2. What about tangent inverse? Now, all these inverse function is as if you are solving an equation, but you only want to look at a certain quadrant. So for tangent, we look at also this two. Okay, so when is it positive? Positive is when we are in the first quadrant, so it's pi over 3. So usually, so what about these three? So maybe we'll talk about this in, do we have time? I think we have time. So we'll go over these two. So if we don't have time, we'll go over it in class. Usually when we see a cosine and a cosine inverse, they usually cancel, right? But not in this case, because cosine inverse take in or only restrict the domain in 0 to pi, but 5 pi over 4 is not from 0 to pi, so we have to actually do it. So we would actually do cosine inverse and then find out what cosine 5 pi over 4 is. Cosine 5 pi over 4 is here. It's still negative root 2 over 2. And then it becomes cosine inverse of negative root 2 over 2, which we have done 3 pi over 4. So you can see that it is not the same as just canceling them. Most of the time we can, but if we restrict the domain for the original function, you cannot. So, and then this is another example where you have a cosine and you do a sine inverse outside. So cosine 2 pi over 3 would be what? Look at the unit circle. 2 pi over 3 is, where is it located? It's here. And what is the cosine value? It's negative 1/2, right? So you actually find out what it is, and then you would do a sine inverse of negative 1/2. Is actually you go to negative pi over 6 that we already did in part A of this. Now the last example is not taken from this book. This book does usually only have this kind of question, but it's taken from other books, because at the end of calculus 1 and I think in calculus 2, you somehow would run into a situation like this where you would need to do a inverse of a tangent, which is an x value, which is a variable. So now this is supposed to be an angle. This is supposed to be a values, right? Supposed to be a value. Oh, I think I might have made a mistake here. So it's supposed to be sine inverse like this, so that this is an angle. Okay, so I should fix it. So we're supposed to find an angle. So to do this, because we don't even know what x is, we would say this angle would be such that tangent of this would equal to x. So tangent is opposite over adjacent, right? And so we need to know the hypotenuse, which is 1 plus x squared square root. Now I am going to do the sine of this angle. So sine theta, you use this right triangle, you will see sine is O opposite of